In the world of high-tech manufacturing, two groundbreaking advancements are rewriting the future of how we build with metal, and trust me, you're going to want to hear this. Scientists from Argonne National Laboratory and the University of Virginia have done something truly extraordinary. They've cracked the code on a major weakness in 3D metal printing. For years, one of the biggest challenges in metal additive manufacturing, especially with laser powder bed fusion, was detecting microscopic defects in real time. Tiny holes, known as keyhole pores, could silently form deep within a printed part, compromising its strength, reliability, and safety. But now, using a brilliant fusion of X ray imaging, thermal cameras, and artificial intelligence, these researchers have developed a system that can see these defects as they form and predict them within milliseconds, even without using X rays for every print. The AI was trained on synchronized thermal and X-ray imagery, and once it learned the patterns, it could spot trouble brewing just from surface heat data. That means with just a thermal camera, which many printers already have, you can catch flaws instantly and eventually correct them in real time. This is a game changer for industries where failure isn't an option. Think aerospace, medical implants, or rocket components. Until now, post-print inspection was slow, expensive, and reactive. This innovation makes the process proactive, reliable, and cost efficient. But that's just half the story. On the other side of the innovation spectrum, the Rubble to Rockets initiative, backed by DARPA and led by Worcester Polytechnic Institute, is turning literal trash into treasure. They've launched a $6.3 million project to transform scrap metal into high performance parts for rockets, no less. Using artificial intelligence and advanced 3D printing, their system analyzes mixed source metals, predicts their behavior, and then melts and remakes them into usable components. Why does this matter? Because in remote areas, disaster zones, or even battlefields, you often don't have access to refined materials, but scrap is everywhere. This new approach doesn't just allow for printing in the wild, it thrives on it. By using AI to predict how unknown alloys will behave, the system eliminates the need for pristine feedstock, making it possible to build with confidence even when resources are limited or improvised. What makes this even more exciting is the broader vision. Imagine a future where these two technologies merge: a mobile, AI powered 3D printer that can use local scrap metal, analyze it on the fly, print precision components, and monitor for flaws in real time. That's not just the future of manufacturing, that's manufacturing on the moon, Mars, or anywhere on Earth where supply chains break down. These breakthroughs solve two of the most persistent challenges in additive manufacturing: real-time quality control and material adaptability. Together, they promise a world where we can build smarter, faster, and more sustainably, whether we're on a factory floor, in a war zone, or millions of miles from home. If this kind of innovation blows your mind like it does ours, hit that like button. Don't forget to subscribe for more cutting-edge science and tech stories, and drop a comment below to tell us, where do you think this technology should be deployed first.